I was telling you that VC is equal to VD. So what happens is no current flows between these. How embarrassing would that be? Actor asking camera on there. Right? Okay, so VC and VD are equal. So that would mean same potential. So no current will flow between them. Is that clear or not clear? No current will flow between them. Now if no current flows between them, this resistor is useless. So it's removed. Okay or not okay? Yes. Sure. Got it? This is the basic idea about symmetries. अभी एक वक्त आपको खबर पड़ी कि बजा काटना पड़ता है। इसे में Wheatstone bridge है आपने काटना नहीं. But sometimes you know when you cannot identify whether it's a Wheatstone bridge or something, then also you could do it easily. Alright? Okay. Well, try this question. It's too easy. So suppose all resistances are R. Let's say all resistances are R and we want to find out what is the equivalent resistance between A and B. Got it, guys? Yes. Do you see that there is the perpendicular bisector exactly dividing the circuit into equal halves, one on left and one on right? Okay or not okay? Sure? Okay? So you do it that way. So here 2 points here, let's say C, this is D, let's say this is E. And which points will be at same potential? C, D and E will be at same potential. So थोड़ा resistors निकल जाता है. Which one? The one between C and D and the one between D and E. You can remove it. बच्चे आवड़ी जाएगा. Method is clear. Why to remove this one? Because this is the perpendicular bisector, left, right, same much. So whether you go here or here or here, the potential differences will be same. So C and D are at same potential. Got it? D and E are at same potential. So E was in because no current will flow. So away. Easy, got it? This is the basic idea. Clear? Okay. तो પછી તો આવડે ને આ બધું R series parallel થઈ જશે. Fine? Yes. Okay. Try this one. એનો આન્સર નથી ફાઇન્ડ કરવાનો તો હવે તો કઈ છે જ નહીં. બરોબર ને? So suppose all resistances are R. Then can you find equivalent resistance between A and B? Is there symmetry here? Yes. The middle line. Both are same. So if I say one point is C here and one point is D here, then their potentials are same. Okay? Fine, their potentials are same. So once you know that there are 2 points whose potentials are same, then we can redraw the circuit. So now there are, if you want, you can do it like this as well. That if you erase right side half of the circuit, if you erase the right side half, so left side will have double karna mein answer aavi jase. Correct or not? Yes. Or not clear? Yes. Sure? Yes. Because what is on the left side? The same is on the right side, and left and right are in series with each other. Parallel nahi. Left and right are in series. Clear? So you could say this point C and this point D are at same potential, and that's why if I erase this one, so आटलाનું resistance find कर नाखी. But these two are same actually. अब इन्हें हम connect कर नाखे तो ये चलते ना? Make sense or not? तो इन्हें हम connect. चलो अबे તો આ બે પેરેલલ થઈ જાય. Do you see that or not?
Yes.
અહીંયા હોય ને અહીંયા હોય, it's the same thing. Understood
Yes.
or not understood? Why so? Because this point is C and D both. Our resistor can attach to from here to C, but from here to D also will be the same because C and D are same. So our resistance to have it. Ready? Same energy. All of it. What kind of creature is you? Exclusive rights. એવું છે તો પણ બારીને માણસે કોઈ હાથ નહીં અડાડે એવું થોડી કામે કોલ એમ કે ડન સમજ તો પડી છે મેથડમાં કે ઉપરથી વહી ગયું
3r/4.
હા
3r/4.
ડબલ કર્યું
3r/4.
because this and then the next one is the same so r r by 2 બરાબર ને r and r by 2 and r 3r by 2 સિરીઝ છે ને ઓકે ઓર નોટ ઓકે શ્યોર કે ડ્રો કરું પરિવાર સમજાય these two are in parallel so r by 2 પછી r એટલે 3r by 2 and r are in parallel okay or not shortcut કાઢે ને બે parallel માં તો શું થાય 3/2 into 1 upon 3/2 plus 1 so that is 3/5 correct or not sure this is only left part હજી આવું ને આવું right માં ડ્રો કરવું હોય તો એમાં આવ્યો જવાબ did you understand this જેવા so final answer will be 6 understood the method yes or no okay but you see the use of symmetry listen to this carefully the use of symmetry is not limited just to potentials erasing it is fine
Yes.
the use of symmetry is not limited just to potential or voltage it is also useful for current cells for example the one that I drawn here there were three branches you have it okay the upper and the lower were identical the middle was different but the upper and the lower were identical yes or no so if you say that the current I1 flows in the upper branch then in the lower branch also the current I1 should flow why so because that upper branch and this lower branch both are identical so currents have to be same make sense sure એવી રીતે ઘણી વખત કરંટ કે છે so this is using symmetry but then dealing with current instead of dealing with voltage got it એવી ઘણી વખત છે so one such question is that example 3.6 3.6 છે ને the one that is remaining this one right so first step would be to draw a cube of resistor tough task that start put the point according to as they are in the textbook diagram okay એટલે કે આંદોલન ન થાય and write all resistors as R only આ લોકો શું લખે છે કઈ લખ્યા જ નથી ને લખ્યા છે resistance લખ્યું છે ક્યાંય નથી લખ્યું ને
No.
we'll put that later okay general case ખાલી draw જ કરો ને વાંધો horrible drawing. Okay. Okay. Points of view. This is A, this is B, C, D. A dash, B dash, now let's read the question. A battery of 10 volt and negligible internal resistance is connected across the diagonally opposite corners of a network of resistors arranged like this. Okay or not okay? Everyone got there? Fine. Determine the equivalent resistance of the network and current along each edge of the cube. That is, for every branch, every wire we will find current. Okay, so first of all, let's connect the battery. So diagonally opposite corners, like A dash and A and C dash. You could have connected between B and D dash also. So make the answer the same. Okay, so it's like this. Now I'm going to indicate the currents in black, so that's easy. Now, first of all, I tell you what has been done in the book. It's not tough, but you have to be a little bit careful with that part. Here, look at this carefully. Instead of assuming usual current I, instead of generally we assume current as I, correct or not? Yes. We are going to assume current as 3I. Why so? Let me come to this one. This is A, this is C dash, initial and final. Okay, from here. Now it's that this is one corner of the cube. Now for a cube, every edge is symmetrical or identical. Yes or no? Yes. That is whether you go across length or height or breadth or width. Yeah. Either way, you are going towards that point in a similar manner. Yes or no? આ કોર્નર થી ઓલા કોર્નર જવો હોય તો આમે જવાય આમ જવાય ને ઉપર જવાય બધું સેમ બનશે. Correct? So what I am saying is that branches AB, AD and AA dash are identical. Symmetry is a cube in length, breadth and height. Did you understand? Or not clear? Whether you go here, here or here, it should be same. So three branches no current same. Which three? AB, AD and AA. But here current coming in is 3I. So અહીંયા બધે equally distribute થઈ જશે ને I and I. Did you understand why we are taking 3I? So પછી અહીંયા I લખો તો અહીંયા શું આવે? I/3, I/3, I/3. Which of them is right? Both are right. Okay, but if you write 3I, then you will have to deal with less number of fractions. તો વધે ટકા કરજો 6I. બરાબર ને? તો કે fractions. Okay, nevertheless, હવે 3I લખી દીધો. ચાલુ રાખો. So I and I will flow. Further, do you realize that this circuit, whether you look at it from A side or you look at it from C dash side, it is same. આ corner અને આ corner વચ્ચે શું ફરક હોય? ક્યુબ માં કંઈ હોય ને, both are same. So do you realize that whatever is going to happen over here at A, similar thing will happen at C dash. Understood? Okay, or another way to understand is current arm flow થાય battery arm. Suppose battery ઊંધી કા નાખો તો so each current reverse થઈ જશે ને બધે. Correct or not? Yes. Sure. And then here what will flow? I and I. But here because the battery is not actually this way but here this way. Correct or not? So it should be I here, it should be I here and it should be I here. Did you understand the 3I? Yes or no? એટલે જેમ અહીંયા split થાય તે diagonal પર merge I and I. So here how much current should flow? Obviously 3. So અહીંયા છે. Understood? So this is what I was telling you about using symmetries for current. Using symmetries for current. It splits in 3 parts, but all the 3 parts are going to be identical in every manner. That's why currents are equal. Got it? So total કેટલી branches છે, કેટલા wires છે? 12 માં એમાંથી 6 નો કામ થઈ. Agreed? 3 here and 3. Not only that, we have explored one more idea. Is that whatever happens coming in from A, the same thing happens here going out at C dash. So this is not just for these things, it will happen elsewhere also. Okay. Now let's go to the corner A dash first. It's easier to visualize over there. From A dash, the current will try to flow to C dash. Okay, I current have. Now going from A dash to C dash, there are two pathways. Which one? Pela D dash jano, પછી C dash. બીજું pela B dash jano, પછી C dash. Okay or not okay? Are both the pathways same? બધું same જ આવે જો. For example, if you go to B dash, એક નીચે વાયર આવે, પછી આમ જાવ તો અહીંયા કરંટ આવ્યો અને આ વાયર. કે અહીંયા D dash જાવ તો એક નીચે વાયર. Then you are not correct or not? So in every way, going from A dash to C dash, there are two ways: A dash, B dash, C dash, or A dash, D dash, C dash. Both are identical. अब तो क्यों सेट लेते हैं? Agree? Yes, sure. So that's why those two are identical, and that's why if current I will come in at this junction, it will split into two parts, and both the parts are identical. That is equal. So what do we get? I by 2 and I by 2. Understood that? Yes or no? Sure? Okay? Right. So we have got A dash B dash covered, A dash D dash covered. Now do you realize that the same logic can be applied to the junction B? From B if you want to go to C dash. From B if you want to go to C dash. Then what are the two different paths? B dash, then C dash, and then to C and then C dash. Correct or not? Path to be same. Yes or no? So if current I will reach here, then how much current will go into B dash? I by 2. And here, I by 2. Understood? Sure. And by similar explanation, you can say that current I reaches here, then half of it will go towards DD dash. Okay, and the half of it will go here towards C. Is it fine? Yes or no? Now there is further, there's further understanding of why we got it like this only. If you will take a plane which acts like a mirror, that plane is going to be from D to B. Center. If you cut it like this, then what we are having is opposite parts are identical. What I mean to say is, AB. What's the opposite edge of this AB? Suppose our room bottom edge. Any opposite edge connect? Yes or no? Sure? Yes. Okay. So if AB is here, then its opposite edge is D dash C dash. Is that clear or not clear? Yes or no? Any exact opposite are there? Yeah. Any exact opposite now? Got it? Yes. So it goes out here, it comes in here. This is due to cement. The cube is divided in two parts. Make sense? The cube is divided in two parts. This and that. Then second one, AD. So any opposite to that? What is opposite of AD? It will be B dash C dash. So there also the currents are same. The only difference is here current comes into it, and here the current is going out. Got it? Yes, no. Yes. For example, take BB dash. Then opposite edge क्या अंदर? D dash. है ना? DD dash. So any opposite edge यहाँ है. Same current same. So you seeing that? Yes or no? Sure. So that's what we are having here by way of cement. The center ની બે side જે opposite હોય તો અહીંયા કોણ છે that where the center is. અહીંયા ઉપરની edge અને ત્યાં નીચેની edge. That will have same current. Is that okay? પછી અહીંયા નીચેની edge ને અહીંયા ઉપરની same current. પછી અહીંયા left માં નીચે અને right માં ઉપર same. Make sense? Yes. So that's how the whole thing is perfectly symmetric. Got it? Okay. તો આ બધા current છે પણ એક્ઝામમાં લખવું હોય તો થોડુંક તો સમજાવવું પડે. ભલે બહુ આપણે વધારે ડિટેલ ન સમજવાની. So let's say this is 10 volt battery. So we can say that current is AB, AA dash and AD are identical, that is equal to I each has all edges at the corner A are identical or symmetrically placed. Right? Similarly, due to symmetry, in circuit, the current in A dash D dash is equal to A dash B dash is equal to that is equal to that in A dash B dash. Okay, that is I by 2E. तो बोला डिटेल समझना नहीं जरूरी. Draw a nice diagram. Okay, and write which currents we are saying are equal. तो पहला आस्ट्रॉन equal, पहले यहाँ पे. Okay. Sorry. अच्छा B में भी. So current in A dash D dash and B C A dash B dash. Okay. A dash D dash and A dash B dash. Right. Fine. Is it okay? Now, just like this, you can have it at every other point as logic stability. Fine. Okay. So, current distribution is as shown in diagram or figure using symmetries. But nothing. હવે બધું વાય ઘડી કેટલી વાર એક્સપ્લેન કરવાનું એક. ઓકે રાઈટ લો કોઈ એવું લાગે છે સિમિલરલી અધર કરન્ટ્સ કેન બી ફાઉન્ડ બરાબર. Okay, not kidding, you will have to write so much otherwise. There is no need to do all that. Fine. બહુ તમને એવું લાગે એક્ઝામમાં ભરપૂર ટાઈમ છે, અરે 15-20 મિનિટ બાકી છે ને હવે એક જ સમ બાકી છે તો કરજો, તો લખજો બધું. Otherwise, this is enough. It will not cost you more than half a mark. You have my word. Okay. બધું લખવા જશો તો એટલી વારમાં બીજો સમ રહી જશે. That's guaranteed. Okay. Anyway, so this is what we have got. Now, we are going to use Kirchhoff's law to find out the resistance. The aim is to find equivalent resistance. Correct or not correct? So, an equivalent circuit draw કરી શકાય. પણ પહેલા એકવાર Kirchhoff's law. Okay. Which branch to take? It's your choice, but we are going to take only one. And एक જ unknown છે. I. You get what I am saying? Yes. Why is there only one? Because we have used symmetry to remove all the other unknown. તમે એકદમ blank કરો ને તો કેવું થાય? I1, I2, I3 clear. That is all થઈ જાય. Patience જોઈએ. Okay, it won't be as easy as this. Got it? Yeah. So we'll take one loop, but it should have battery. I hope you remember that battery decides the current ultimately. So if you take a loop without battery, then you have to get 0 equal to 0. Congratulations. Okay, so we will take loop with battery. So using Kirchhoff's loop rule, for what do you think we should use it for? Choose one. Take the shortest. રખડતા નહીં બધે ગામમાં. A B C C dash Y X અને A. બરાબર. For with loop for A B C dash Y X and A. Okay. ગમે તેનો આન્સર આવશે, don't worry about that. But try to take the shortest. So come વધારે ટોપ લખીને કોમ્પ્લિકેટેડ કરું. So what do we get? Minus AB માં શું આવશે પહેલા? बोलो बोलो फटाफट माइनस I into R. Okay or not okay? अच्छा હું આ લખું છું આની વાત પછી I just want to do it generally. Alright, I into R પછી BC minus I by 2 into R પછી CC dash minus I R. What do you can do? So back all the way here plus 10. Okay, 1 plus epsilon is equal to 0. Understood? समझ पड़ी क्या ना? Sure. अब इसे करो. Simplify. IR 2 IR ना I by 2 है 5R by 2 देखिए ना. So we get n is equal to 5 IR by 2. Okay. We get n is equal to 5 IR by 2. You can simplify it and you can say I into R is equal to 4. Okay or not? Sure. Fine. R equal to 1 say તમે લખો તો I equal to 4 આવે. Right? R is equal to 1 મૂકી દો suppose. તો શું થાય? I is equal to 4 ampere. I is equal to 4 ampere. But 4 ampere is not the current through battery. How much is the current through battery? How much is the current? 3 ampere. 12 ampere. 3I. That is 12 ampere. Okay or not? 3I. समझाओ ना? I is 4. 3I. 12. Clear or not clear?
Yes.
I is 4. So 3 into I is 12. અહીંયા 12 ampere. પછી અહીંયા 4 ampere, 4 ampere, 4 ampere. એવું તો છે ને? પછી આગળ બધે split થશે. Is it fine?
Yes.
Are we ready to find current in all the branches? Sure. Absolutely. Well. It will take you. Okay. Now, what about equivalent resistance? For that, we'll keep this aside. Okay. Now, we will draw equivalent circuit. Okay. What meaning of equivalent circuit? There should be equivalent resistance which performs the same thing. Does the same thing as this. Clear or not clear? Easy enough to understand?
Yes.
Okay. How much is this 10 volt? How much will be the current? 12 ampere. 3I. That is 12 ampere. Understood or not?
Yes.
That's one of the most common reasons. અહીંયા 3I લખવાનું એ risk. કેમ? અહીંયા તો તમે 3I કરી નાખશો બરોબર. પણ જ્યારે આ કરવાનો હશે ને ત્યારે 3I યાદ નહીં આવે અને શું યાદ આવશે? I. The answer photo. સમજાણું ને? Okay, so of course the good thing about this method is you are avoiding some fractions, but there is also a risk here. It's minor one, of course. ध्यान रखो तो कहीं वांधो ना આવે. Okay, so this is it. So now for equivalent circuit, we have what? 3 into I into R equivalent is equal to 10. Correct or not? Easy to understand?
Yes.
Current into resistance should give us the voltage. Fine or not fine?
Yes.
So, હવે આપણી પાસે બધી વેલ્યુ છે છે કે નહીં? શું છે? અહીંયા જો I into R equal to 4 આવ્યું હતું ને? If you are doing it for general, okay, we can put I's value from here. How much is I's value? 4 by R. સમજાણું કે નહીં? એનો સમજાણું?
Yes.
So simplify this. What do we get? Therefore, R equivalent is equal to 10R by 12. That is how much? 5R by 6. Clear or not clear? ये confusion નથી થતું ને? ક્યાંથી વેલ્યુ લીધી? અહીંયા દેખાય છે IR ની વેલ્યુ. IR is 4. So what is I? 4 by R. Is that okay or not okay? IR is 4. So I is 4 by R. I put that up there. Got it? What's the other way to do it? We can also do it like this. Current 3I should be equal to voltage upon R equivalent. Yes or no? 3I ની value 12. Agreed. What is the value? 10 upon R equivalent. So what is R equivalent? 10 by 12 ohm. That is 5 by 6. And here R is 1. So if we put R value as 1, what do we get? 5. Method clear both the ways. In a general formula, if there is a cube of resistor and you are connecting this point and this point between the band figure, then what will be the final answer of this equivalent resistance? 5 R by 6. આ બધું 2 2 2 2 2 હોય તો એને 2 મૂકી દેવાનું, 5 હોય તો 5 મૂકી દેવાનું. Got it? For accordingly whatsoever it may be. Everything is clear? Pretty sure? Out say ne? So that's how you do it by the textbook. But of course we can do it by exploring points and taking their symmetries. What I mean to say is, here do you realize that D, B and A dash are same point? I'm teaching other method. Chapter is over from textbook. Do you realize that D, B and A dash are same point? No, not same. આ point અને આ point. અહીંથી કરંટ બધે આ જ છે. આ બધા રેઝિસ્ટર એ સેમ જ છે. તો આ ત્રણેય point identical જ હશે ને? Make sense or not? Absolutely sure. Okay. Similarly, correspondingly close to C dash, there are 3 points which are same. Which 3? D dash, B dash and C. Understood? These are 3 points which have same potential. समझ पड़ी ने? समझ पड़ी? और बाकी सुनी? ठीक है, बाकी रहो कि नहीं? बता सही क्या? Okay. So now let's redraw the circuit. Very simple. Suppose you redraw the circuit. Using point potential. This is A, this is C. Did you understand? 4 is जगह आ गया मोटर ड्रॉ करना. बहुत बड़ा resistor. How many are there? 12. And close to A we have the points D, B, A dash. And close to B, C dash we have points. Which points? B dash, B dash, and C. Now I'm not saying this method is easier or anything. It would depend heavily on your preference. Okay, I must be black ink out. Okay, let's start. So first of all, let's label them. Okay, and 1, 2, 3, 4. 1, 2, 3, 4 on the floor. Let's see, 5, 6, 7, 8 on the ceiling. Alright, left side 9 and 10, and 11 and 12. 12 there. So let's start. So A, B, number 1. અહીંયા આવશે. Okay, એવી રીતે 3 આવશે ને? You realize that 1, 9, 4. Correct or not?
Yes.
Sure. 1, 9 and 4. 3 આવી જશે. So all the 3 are in parallel. So they give R by 3. Why R by 3? 3 draw કરશો એટલે parallel નો 3 4 બે. Got it? કયા પતી ગયા? 1, 9, 4. એ આ બાજુ 3 પૂરા કરો. 7, 6, 7. Okay. હવે શું બાકી? 2. 2 is between B and C. Okay. Fine. 2 is between B and C. 3 અહીંયા થઈ ગયા, 3 અહીંયા થઈ ગયા. બાકીના બધા ક્યાં હશે? આ અહીંયા જશે ને? Yes or no?
Yes.
તો કેટલા હશે? 6. કરો. All are in series. Understood? That's one answer. How do you do it? So, to be very frank, if you cannot write R by 3, R by 3 and R by 6 directly, this method can be very irritating. Draw to kari do, 12 cover padi jase. So if you can do it without writing, then this really helps. બરાબર ને ડ્રો કરો એટલે તરત જ ખબર પડી જાય કે કેવી રીતે આન્સર આવશે. તો again r parallel એટલે r by 3 લખી નાખ્યું એટલે અહીંયા r parallel r by 3 understood. બાકીના બધા ક્યાં છે between these 6 points whatever they are, r by 6. બરાબર understood. Method is clear. So like this you could do it, right? Even the same method works for capacity. बराबर ने. There is one more method, not just for this question, in general. The method is, listen to this carefully, it's like a hybrid between this and that. You do it the next time. Right? It was your bell or for the ninth one? Turn it off.